So there are some different aspects of physical chemistry, like how many moles are required. Like if we have any reaction which is going from A to B, then there can be different aspects of how many moles we have taken here, how many moles will be formed. So that will be considered in basic principles of chemistry. Then you have some how much heat is required, how much heat is evolved. Then that you need to study in thermodynamics. And one aspect is that how fast this reaction is going, like in how much time this A can be converted into B, that you need to study in chemical kinetics. Okay, it's like basically we will study rate of the reaction in both equilibrium and non-equilibrium condition. Rate of the reaction, basically speed, you can say. Okay, so if you wish, you can write the definition. Chemical kinetics is the branch of science, or you can ignore also, no problem. But basically it deals with both equilibrium and non-equilibrium reactions. Okay, and change in the rate
No,
of
wait, what is the meaning of equilibrium and non-equilibrium? As in,
equilibrium,
like,
like see, there will be some reaction like A to B. This is like single step reaction, or this is not reversible reaction. Okay,
hmm,
and there can be certain reaction which can be reversible. A is going
hmm,
to B, and at the same time B is going to A. You know the basic difference between reversible and non-reversible.
uh-huh.
You know the basic difference.
Like, which it can happen A to B, but it can't happen B
Yeah,
to A.
it can go from A
Like,
to
say,
B.
a rusting of iron is
Yeah, rusting is
irreversible.
irreversible. Yeah, and conversion of ice to water is a reversible. Okay,
Irreversible.
so this reaction attains equilibrium, like there will be some at point where A will be converting into B and B is converting into A, and you will feel that the reaction has stopped. But basically reaction has not stopped. Basically A is forming into B, and at the same time B is also forming into
Okay,
A.
it's just equal,
Yeah,
so we
equal.
notice no
Yeah, so
change.
that is equilibrium. So chemical
Hmm.
kinetics, we will study the equilibrium reactions also. This is applicable for both equilibrium reaction. Okay, fine.
Right.
The first thing, like definition we can ignore, you can see from the textbook also. Okay, so what is the rate of reaction? So what is rate? Rate, you have some general idea what is rate. So rate is like the
Mount.
change, there is defined as means something change, any change or change in any parameter with respect to time, that is called rate. Basically with respect to time, any change with
Rechange.
respect to time, with respect to time, WRT, can you understand, with respect to time. Okay, like if we are taking talking about velocity. So
Huh.
velocity, it is the rate of change of distance with time, you can say. Then we have
Hmm.
acceleration also, acceleration, rate of change of velocity with time. Then we have speed also. So these are
Huh.
called, these are some changes with respect to time. So here also we will see the rate of reactions, there will be something change with respect to time. So what kind of change we will see here? Here we can see the velocity, acceleration, but here we can't see molecule moving with any speed or any velocity. But we see that here reactant is going into product. Okay, so
Hmm.
there will be some concentration of reactant, there will be some concentration of product. So with respect to time, as the reaction will proceed further, so there will be some change in the concentration of reactant, there will be some change in concentration of product. So that
Huh.
change in concentration we will study. Okay, so the rate of reaction is, rate of reaction basically, next time I will write ROR. ROR means rate of reaction. So that will be
Hmm.
change of concentration, change of concentration. And concentration is for both, for reactant also and for product also. So it doesn't mean that only reactant or product. Rate of change of concentration of reactant or product, both, with respect to time, means rate of change of concentration of reactant or product in per unit time, that we will call rate of the reaction. Okay, so we will deal with the concentration terms only. Now see how we will deal with this concentration term. Suppose we have a reactant and we have a product. So if we start the reaction, which is we denote as time as t is equal to 0, like we have just started. So this reactant, concentration of reactant, suppose we say that this concentration is C molar, just I am taking it as C. Okay, any value. Then at the, when we have started the reaction, the concentration of product will be 0, because product has not formed, we have only reactant, we have started the reaction from reactant to product, you got it. So at
Hmm.
initial time concentration of product will be 0, because it has not started forming product. But if we will see after some time, so I am taking a T is equal to T, these are the general notations, okay, T is equal to T. So there will be some formation of product, so that I am writing at C2, okay, and there will be some concentration of reactant which will get decreased. Initially we have taken C, but after some time the remaining concentration will be C1, and the concentration of product which is formed is, that is called
But
C2.
is it like the same value? Whatever we minus from C,
Yeah,
it goes to C2?
just think yourself, just think
Hmm.
yourself at any time t, suppose we have taken C molar, so this
Hmm.
C1, so C1 will be maximum, this will be equal to, less than equal to, or more than C1, like C,
Less, right?
which one will be higher value, C1 or C?
C would be higher than C1.
Of course C will be higher. You take any
Hmm.
concentration any time, then of
No, no, I
course,
was saying whatever we subtract from reactant, all of it goes to the product.
yeah, all of it goes to product, okay. So
Hmm.
at any time we see, so this concentration of C will be always greater than C1, always,
Hmm.
okay,
Hmm.
fine, this is okay. So like,
Yeah.
if we will see the rate of change of reactant, we can see for both. So rate of change of reactant, so basically we do final minus initial, like A is changing to B, so what will be the change? So final minus initial divided by time. Basically we do the same thing for what we, if we do any kind of like change. So final minus initial, what is final? Final is C1, initial is C divided by some time, so divided by T. So just tell me whether this value will be positive or negative. So of course this C is always higher, this C1 will,
Negative.
C1 will be always smaller than C, so this term
Hmm.
will be negative, remember this part. So whenever we do any change of reactant, like if we will write direct expression for reactant, then that will comes negative always, okay, fine. Now
Right.
at the same time, if we will do the rate of change of product, rate of change of product, so of course we will do C2 minus 0 divided by time. So of course this C2 is a positive value, and anyway
Hmm.
this will be higher than that, so that will be a positive term. So whenever we will write the rate expression for reactant, that we have to
Hmm.
include a negative sign, and when we will write the rate expression for product, then we will write in positive sign, okay, this we need to
Right.
remember. So this is concentration term, concentration divided by time. So if we will to write the unit for unit of rate of reaction is equal to, so this is concentration divided by time. So the unit of concentration is what? Moles per liter, this
Hmm.
you remember,
Moles per
moles per
liter.
liter, and time is, you can take seconds, so per second. Dimension analysis we do like this only. So the unit
Hmm.
of rate of reaction will be this one, remember this part, okay, this is.
Huh.
So there is some difference between average rate and instantaneous rates, that is the same as average velocity and instantaneous velocity. So here basically suppose we have to take
So
the
this is
unit,
instantaneous, right? At time t.
so time t, so if there is more duration of time, that will be average, like suppose you are going from Delhi to Bangalore, suppose, okay,
Huh.
and there will be some distance, suppose 100 kilometers. So from
Hmm.
100 kilometers, how much time you have taken to cover 100 kilometers? Suppose for 100 kilometers you have taken around 2 hours, okay. So
Huh.
what will be the average speed? So average speed means the total distance by total time, that is average, okay.
Hmm.
But
Hmm.
there can be some instant where you might have drive at 80 kilometer per hour, or some time you might have drone at 20 kilometer per hour. So
Huh.
your speed might have this not have been uniform now, this is the
Huh. Huh.
average speed. Like if we will go from average speed, but sometimes your vehicle will be slow, sometimes your vehicle will be fast, okay.
Huh.
So suppose if I ask you instantaneous, like at this moment what is your speed, so instantaneous means you have to reduce this value, we will see from the graph, okay, we will see
Hmm.
from the graph, just see the graph how it will look like, reactant and product, then you will understand in better manner. So suppose I draw one graph for concentration and here time, okay. So if we
Huh.
talk about reactant, so initially reactant concentration will be high, but as we will proceed further, then the concentration of reactant will go on decreasing because it is converting into product. Okay,
Hmm.
so initially concentration rate of reactant concentration will be high and it will go on decreasing. Fine. Then if
Hmm.
this is for reactant.
Hmm.
Fine. If we talk for product, then initially at 0 time product will be 0 at 0 time. Then as
Hmm.
time will go on increasing, the concentration of product will go on increasing like this. Okay, so this is the graph for product. Okay,
Also, why not why a curved line?
why curved line? Because this is not like this is not directly proportional. This is not directly proportional. If it is
Oh.
directly proportional, then directly we can draw a straight line, but it doesn't. Sometimes reaction may be fast, sometimes reaction may be slow. So it is like reaction. Now we are not driving any car or anything, so that's why it is not a straight line. We generally we take it as a curve. Like sometimes you may need to heat so that the reaction will proceed. Sometimes you need to add the catalyst. Sometimes there are different aspects. Okay, so that's why we don't take as a straight line. Okay,
Hmm.
otherwise
Hmm.
this graph, as the time will increase, then the concentration will increase. That's why we take this kind of line only. Okay, so suppose if we
Right.
take any curve for reactant, suppose we take, so reactant, the graph was something like this. Okay, so this is
Hmm.
concentration and this is time. So suppose we want to take average rate. So average rate means we will have to take concentration at this point and time at this point. We have concentration at this point and time at this point. So rate is average rate,
Hmm.
like v2 minus v1 by t2 minus t1 we see for velocity. So here it will be c2 minus c1 divided by t2 minus t1. Here the concentration is c2, here the concentration is c1, here the time is t1 t2 sorry, and here time is t1. So this is how we calculate the average rate or average velocity, average speed, whatever, b2 minus b1 divided by t2 minus t1. This is the common one only. This is the average rate. But if we want to calculate the instantaneous rate,
Hmm.
instantaneous rate, so instantaneous rate means, suppose this is delta c, so delta c by delta t, this is average rate. But as we decrease, we go on decreasing the time, means as t tends to 0, if we will take particularly at this point, particularly at this time point, then delta t we are decreasing. Previously we had this much gap, now we have only this much gap, only one point. At this point we
Hmm.
have, so t2 minus t1 we are decreasing. So that's what I am saying, delta t tends to 0. So that will become dc by dt, dc by dt. Basically we are
Oh, no, wait,
decreasing.
I didn't understand that part. Why did we say t tends to 0?
T tends to 0. Why we said t tends to 0? This is the average rate. Okay, so
Uh-huh.
t2 minus c1 divided by t2 minus t1, this is average
Uh-huh.
rate. But
Uh-huh.
suppose I want to know the instantaneous rate.
Hmm.
Instantaneous rate means at exact point. So what will be the
Hmm.
gap between two points? What will be the gap of
T2
time?
minus T1, right?
T2 minus t1, but that gap will be more or high?
More or higher?
I didn't understood. Like suppose this distance between Bangalore to Hyderabad, suppose Bangalore to
Uh-huh.
Hyderabad is 100 kilometer. Okay, so
Uh-huh.
the total time was suppose 2 hours.
Uh-huh.
Okay, so basically average rate is how much? 100 kilometers divided by 2 hours, that is your average speed. Okay,
Right.
but
Right.
suppose you have to know the exact position here, what was your speed. So this is the
Yeah.
frame here, so this can be 5 minutes. Okay, instead of 2 hours. So t2 minus t1 will become 5 minutes. So that was your average speed, instantaneous speed at that moment. Sometime
Uh-huh.
even at particularly 1 second you want to
Was
know.
it wait? T tends to 0 as in just a small interval.
Yeah, a
Is
small
that what?
interval. Yeah.
Ah, okay.
This is a
Okay,
small
okay,
interval.
then I understood.
You understood? This is
Hmm.
mathematics point. This is like if
Hmm.
you go on in decreasing the time interval, if you will go on increasing the time interval.
So basically, T tends to 0 represents like a small time
Yeah,
interval.
a
What was
small
the
time interval.
instantaneous
Yeah,
rate?
a small time
Okay.
interval.
Okay, understood. Understood.
Understood? You got it? So
We can proceed.
if the time interval is very small, then you can get the instantaneous rate
Hmm.
basically, or instantaneous speed. Okay,
Right.
like if we can know at 1 second, very small value will be 1 second. Even if you see any kind of like Olympic game, then fraction of second will also matter. So that is
Hmm.
not less than 1 second. Basically what we are doing, we are decreasing the time to 0. Basically it is not exactly 0, but it is almost equal to 0. T tends to 0, then we will
Right.
get the at exact moment. Even 1 second is also not exact moment. Okay, got it? So this is, in mathematics we call it differentiation. If we will differentiate this
Hmm.
one, then we will get instantaneous rates. Okay, and instantaneous rate means we will draw the tangent. If we will draw the tangent, then we will get the exact instantaneous rate. Okay, the slope of this tangent will give instantaneous rate.
Right.
Slope of this tangent will give instantaneous rate. Fine. Okay, so the rate for the reactant will be always decreasing and the rate of the product will always be increasing, that you need to remember. Okay, now how we will express the rate of reaction? Okay, so the rate of reaction based on a stoichiometry of reaction. Write down rate of reaction on the basis of a stoichiometry.
What's the meaning of stoichiometry?
Wait, I'll tell you. A stoichiometry. A stoichiometry of reaction. A stoichiometry means you will have all the information how many moles of reactant or product has been taken. That is called a stoichiometry. Like if we have any reaction, A plus B plus C gives C plus D. Keep gap in between, okay, because I will write something more. So this is the general reaction, but we don't know the stoichiometry. Why? Because we don't know how many moles of A we have taken, how many moles of B we have taken, how many moles of C is formed, how many moles of D is formed. We don't know. So we will write a stoichiometry.
C is there on both the sides.
A, B, C, D, E, you can say
Oh.
D and E. Fine. So A, B, C, D, E. So suppose we have taken N1 mole of A, then
Huh?
N2 mole of B and
Mm-hmm.
N3 mole of C. This is called a stoichiometry. How many moles we have taken? Okay. Then
Mm-hmm.
this is D. So we have N4 mole of D and we have N5 mole of E. So this much mole we have taken and this much moles of product has been formed. So rate of the reaction, how we can write? So just now we have seen that rate of reaction can be expressed in the terms of rate of decrease of A or rate of decrease of B or rate of decrease of C, which is equal to rate of increase of D or rate of increase of E. By both the contexts we can say, like suppose I can take the kitchen example. Okay, so the kitchen example means some your mom is cooking of some making chapati or bread, something you can say. Okay, so there are reactant, we have some kind of flour and then it is converted into bread, you can say. So how will you determine the rate of a speed of this reaction, or you can say formation? So as the amount of flour is getting decreased, you can say that okay, bread is making this much fast or this much speed, or you can determine from the bread also, like in 1 minute how many breads are formed. By this way also you can determine the rate. You understood or not? Like how much speed this flour is like decreasing or how much fast the bread is increasing. In both the way you can determine the speed. No need to see only bread or flour. Okay, so basically
Right.
either reactant or product, you see anything, you can determine the rate. How speed the reactant is decreasing or how speed the product is increasing, that will determine the rate. So that will be equal in, like if 1 kg of flour is decreased, so 1 kg of bread will also be formed. Got it? If 1 kg of bread is formed, means 1 kg of flour has been decreased or used. So basically write in any way. So that's what we write. So we use coefficient here. So coefficient here we will write minus sign. Why? Because it is reactant. So we will write coefficient in the denominator, 1 by n1 into d of concentration, change of concentration of A with respect to time. Got it? So this will determine the rate, or we can determine from here also. So this will be equal to minus 1 by coefficient of n2 into change in concentration of B with respect to time. Got it? Or this will be equal to rate of change of C also. So minus 1 by n3 into change of concentration of C with respect to time. This you are able to understand or not?
This is for the
This is
reactants.
for the reactant. So this all will give the rate of reaction, all. Or even you can write for product also, but since it is forming or it is increasing, so we will write positive value. So 1 by, write your own, 1 by n4 into change of concentration of d with respect to time, change in concentration of dt, or
So
write
this is
here.
not equal to the rate of reaction
Yeah,
equation,
of
right?
course it will be equal.
Okay, that's also equal.
That also will be equal. And then
Uh-huh.
it will be equal again with E. So write this expression for E. So
What does dA by dt means? The concentration?
change
No,
of concentration, change of
change of
concentration of
concentration with respect to time.
change of concentration of A with respect to time. We call it dt.
Uh-huh.
Okay. This
Right.
what I have written here instantaneous. This is dc by dt.
Uh,
dc by dt, change of concentration by time. So this is change of concentration. So here it is change of concentration of A, here it is change of concentration of B, here it is change of concentration of
okay.
C, it will
All
be
right, all right.
D. So write this term, what I will write for E, just
1 plus 1 by nf n5
n5
dE
into
by dt.
D into E
So
by,
how will a question look? How will questions come from this?
yeah, just wait for a moment, we will see, just remember all this part. Okay, we will see the questions also. Okay, so these are the change of concentration with respect to time, and all will give the rate of the reaction. So here we have
Right.
some different terms. Here we have some three types of terms. So one, if I will write like this, 1 by n1 into d of A by dt. So this is the change of concentration of A with respect to time, and I am including coefficient also. So this will give rate of reaction. You write with coefficient, or any term you take, all will give rate of reaction, all will give rate of reaction, you take anything. Okay, fine. Then I can also write excluding this coefficient. So I can write here d of A by dt. I have not included the coefficient. So this represent change of concentration of A with time, not coefficient, change of concentration of A with time. So I can write here rate of disappearance or consumption of A. Can we write rate of disappearance of A? Got it?
Rate of, yeah.
Rate
It's
of
decreasing, right?
yeah, rate of disappearance of A we write. So d of A by dt, don't include the coefficient. If you included the coefficient, that will become rate of the reaction. Okay, or I
Right.
can write here d of, like I will write, take this next page. So I can write here positive value d of d by dt. So this is in the product. So what will be the means value
Rate
for,
of appearance
yeah,
or something.
rate of appearance or formation, rate of appearance you can say, or you can say rate of formation, or formation,
Of D.
yeah, formation of D. So this you can write for anything A, B, C, D, E. Rate of
Hmm.
disappearance of A, B, C, D, you can write rate of uh, disappearance for A, B, C, you can write, or rate of reaction you can write. Got it? So if you include the coefficient, that will become rate of reaction. If you don't include the this part, then that will become rate of formation of disappearance. Okay, so just take one question, you will understand. So this is, I am writing one reaction NH3 plus oxygen, that is gas, gives NO gas plus H2O. Okay, so if you will balance, then just write it down. This is like 4, and this is 4, and this is 6. So this is the coefficient. Na plus N2B gives N3C plus N4D, whatever. Okay, so they have given the change of concentration of NO, the concentration of NO means this one. Okay, increased by, 1.5 molar in 10 second, this information they have given. The concentration of NO is increased by 1.5 molar in 10 second. Calculate the rate of reaction. Calculate first part, rate of reaction.
Hmm.
Then you need to write rate of disappearance of NH3 and O2. Rate of disappearance of NH3 and O2. Then one more question in this part only. rate of appearance of H2O, rate of
The product.
appearance of H2O. Anything they can ask, H2O also they can ask, anything they can ask. Okay, fine. So they have given rate of formation of NO, they have given. Okay, rate of formation of NO they have given. How much? 1.5 molar in 10 second. Okay, so how
No,
will,
basically dA by dt, right? Which they gave.
yeah, they have given dA by dt. So what they have
Yeah.
given? So they have given positive of dNO
Huh.
by dt they have given. Okay, so change in concentration of NO they have given, change in concentration, this is what? Change in concentration of NO by change
Mm-hmm.
of time. So what they have given? Just tell me. Change in concentration of NO they have given 1.5 molar,
Huh.
and change of time they have given 10 seconds. So
Hmm.
dNO they have given, dt they have given, so this they
Huh.
have given. Fine.
0.15.
Yeah, 0.15 whatever. Okay, so
Hmm.
0.15, 1.5, or this is yeah, 0.15,
Hmm.
0.15 moles per liter per second, mole per liter per second. But one more thing, suppose we have to calculate rate of the reaction. So how we will get rate of the reaction? So can you write rate of the reaction in terms of NO?
Rate of the reaction in terms of NO,
Yeah,
minus 1 by N1.
write the rate of the reaction in terms of NO. So use
So
coefficient.
1, so this
uh,
0.15 by 4.
yeah, 0.15 by 4. So rate of the reaction will be ROR will be is equal to 1 by 4 because coefficient is 4. So d of NO divided by dt, that's it. So this is called rate of the reaction, so that will be 0.15 divided by 4. So this is your rate of the reaction. Fine.
It's positive, right?
Yeah, this is positive value, rate of the reaction is positive. Fine. So
Hmm.
this is rate of reaction which you have got it. So even you can write rate of the reaction for everything. Okay, rate
Hmm.
of reaction for everything you can write. So no need to write rate of the reaction, but just see what else is required. So rate of disappearance of NH3 and O2 they have asked. Okay, NH3 and O2. So how we will write rate of disappearance of NH3? How we will write from the equation?
But we don't know the dA by dt for NS3, right?
Yeah, we don't know. Just you first tell me now how we will write. How we will write?
Yeah, it'll be 1 by 4.
Yeah. 1 by 4 minus
Minus 1 by 4 dNH3
hmm,
by dt.
by dt. This is bigger bracket. Okay.
Huh.
This value you need to know. This value you will know, then you will understand you will find out the rate of disappearance of NH3. But
Hmm.
this is equal to the rate of reaction. Can you
Hmm.
say all the terms
Hmm.
are equal only, no?
All are equal.
All are equal. So this will be equal to this term also, equal to
Hmm.
1 by 4 into d of NO by dt. Will this be equal?
Right?
This is also 1 by 4 or 1 by 5. Yeah, this is 1 by 4. So 1 by
4.
4, 1 by 4, this will be equal. So what will be the rate of disappearance of NH3? This value you know.
Huh.
This value we know. This value is 0.15 by 4. So rate of disappearance means dNH3 divided by dt. This is rate of disappearance of NH3. Rate of disappearance of NH3. It will be equal to this one, d of NO by dt, means this will be equal to 0.15 divided by 10. That's it.
Huh.
Is this okay?
Right. Okay.
This is okay. Now again, rate of disappearance of what? This was rate of disappearance of O2. Okay. So for O2 we can write how much? Minus 1 by 5 into rate of disappearance of O2 divided by dt. This will be equal to again this part 1 by 4 into d of NO by dt. Can we write?
Mm-hmm.
So rate of disappearance of dNO2, what DO2 what will be? So DO2 by dt is
Minus
equal
5
to,
by 4
yeah, minus 5 by 4 into
dA by dt.
dNO by dt. This minus sign means it is decreasing. You can write just value, otherwise it is decreasing, means it is in reactant, so of course it will be negative only. Okay, got it? So this is how you can write. Now the question is asked, what is the rate of formation of H2O? That also we can write. So rate of formation of H2O, how we can write? So H2O was 6, so 1 by 6 into d rate of formation of H2O divided by dt is equal to 1 by 4 into dNO by dt. So rate of formation of H2O also you can calculate. So rate of formation of H2O, which is dH2O by dt, is equal to 6 by 4 into dNO by dt. So if they will give even one concentration, they will give, and one time they will give, you can calculate for everything. Any one will give you the rate, any one will give you the rate, because all are equal term only. That's what I wanted to say. Okay, all are equal term only. Rate of disappearance will be equal to the rate of disappearance of this, will be equal to rate of formation of this, will equal to the rate of formation of this. So if any value you know, they can find for any value, all the rate will give equal, and from that you can get the rate of disappearance of this one, or rate of disappearance of this one, or rate of formation of this one, or rate of formation of this one. This is okay?
Right.
This okay? Yeah,
All right. All right.
yeah, fine. So these types of problem, they will means you can get in any book. You can just solve, or I will provide you. Okay, in any book, even in NCERT also you will get these kind of problems. Okay, fine. Then we will move to the next topic, that is law of mass action.
Law of mass action.
So the law of mass action, like if we write any rate law, okay, then the rate of reaction is directly proportional to the active mass raised to the coefficient. Didn't understood me. Like suppose we write, just leave some small space here. Suppose we write the rate law. So we will write rate of reaction. Any reaction we take, suppose N1 plus N2, N2A plus N2B plus N3C. This gives the product. So the rate law of mass action say that the rate of reaction is directly proportional to the active mass of the reactant. So active mass means concentration of A, concentration of B, and concentration of C. These are called active mass. The mass which is like in
No, active mass isn't the concentration.
yeah, concentration. Like active mass is not exactly like the reacting species we denote in active mass. So if we are doing this reaction in solution phase, then the concentration will be the active mass, like molarity will be the active mass. But if we are doing the same reaction in gaseous phase, so partial pressure will be the active mass. Okay, so here the concentration will be the active mass. So the rate of the reaction will be directly proportional to the product of active mass with the power of the coefficient, raised in the power of the coefficient. So this power will be n1, this power will be n2, this power will be n3. So this is called law of mass action. Got it? The rate of the reaction is directly proportional to the product of active mass raised to the power of their stoichiometric coefficient. So you can write it down. The rate of reaction, the rate of a reaction is directly proportional to the product of active masses, to the product of active masses of reactants, not products. This is for reactants raised to the power of their stoichiometric coefficient.
So just what we wrote below is stated in volume.
Raised to the power of their stoichiometric coefficient.
So if the reaction is not balanced, we always have to balance it.
Yeah. Stoichiometric coefficient. Fine. So this is law of mass action, and here this is directly proportional. So means if we will remove this proportionality constant, then we have to write one constant, or rate is equal to, then we will write one constant k, then concentration of A to the power n, then concentration of B to the power N2, here N1, N2, and here concentration of C to the power N3. This K is called characteristics constant, and that is called rate constant. So K is equal to rate constant. So this is how we have derived this term rate constant, okay, from law of mass action. Okay, one thing is there, active mass. So active mass, I have told you, if we are doing the reaction in solution phase, then active mass will be molarity, okay, and if we are doing the reaction in gaseous phase, then the active mass will be partial pressure, or even molarity also possible, but maximum
Wait,
it will
wait,
be
can you
pressure.
repeat that once? In solvent phase, it is
Yeah,
molarity.
molarity, active mass.
And in gaseous phase, it is?
Active mass molarity, molarity, molarity if it is solution phase.
And in gaseous?
In gaseous phase, partial pressure.
Partial.
Gaseous state, partial
Wait, what we
pressure.
did in solutions, right? P naught.
Yeah, in this, yeah, in the solution also we have seen partial
Okay.
pressure. So that is the active mass.
Hmm.
Okay, fine. So one more thing, this is the rate expression or rate law. But one more thing, that what all the things we need to include in the rate law, which you need to remember. Okay, so suppose this, you have some intermediate. Do you have any idea of intermediate? We have studied in organic
No,
chemistry
like
also. They will be,
inorganic, also a step in
yeah,
between.
steps in between. It is formed and consumed in the in between the reaction. So never include intermediates in the rate law. So write it down. Intermediates are not included in rate law. So
Like, how do we know if it's the intermediate or not?
see, if you have some multi-step reaction, then
Huh.
if some species is formed and that same species is consumed in the middle, then that is called
Hmm.
intermediate. Like there are some several step reaction. A plus B gives C, then again you have C plus D gives E. So what you do is just, or C plus D gives E, then what you do, just add these two reactions, whatever all the reaction is given to you, just add up. Okay, so if I'll add C plus D, C plus D gives E, so we are adding, so this will get cancelled, this will get cancelled. So what we have formed here, A plus B plus D gives E. So here we can see that C has been eliminated, so C is a intermediate here. Got it?
Hmm.
And even
Okay, like
D,
that.
here it will become 2D. No, here only A plus B plus D gives E. So C has been eliminated, so C is intermediate here. So what all the reaction is given to you, just add up all the reactions by equating this in a stoichiometric coefficient. If it is 2 molar, write here 2 molar, and if they are getting cancelled out, then that is intermediate.
So what exactly is the intermediate here? A plus B?
No, intermediate is C,
C
because
only.
C is formed here and again C is consumed here. That's why it is getting cancelled out. So the overall reaction will be A plus B plus D, A plus B plus D gives E. So here we can't see any C here, so this will determine the rate law, not this one or this one. Understood?
Okay.
So this is in intermediates are not included in the rate law. Got it? So this is one point. Another point, that the reagent which is present in excess, that we don't include in the rate law. This is the second point. The reagents which is present in excess, is not included in rate law. How?
Right.
So you have one example, like this ester plus H2O. We will do reaction and it will form acid plus alcohol. You might be knowing acid plus alcohol. So this water we are taking as a excess. We are taking excess of water. What is the meaning of excess of water? See, suppose you want to make rice, okay, any rice you want to cook, but this rice you don't want to cook at in your kitchen. Suppose I told you, you go beside any river, and there you cook rice. Okay, so what are your reactant? Reactant is basically your rice plus water.
Water is unlimited.
Yeah, water you are taking from river only. Okay, so at the same time rice will getting decreased, but if you take 1 or 2 quintals of water from the river, so will it matter? Water will decrease anyway, it will not decrease. Got it? So that's why we say that any compound which is in excess, so that we do not include in the rate law. How much amount you can take water from river, anyway it is not going to decrease. So basically here also, so here ester, for this esterification reaction we are using this H2O as an excess, so we don't include this ester water in the rate law. We will include only ester part. So rate, how it will be determined? So rate is directly proportional to rate constant in the concentration of ester only, and we will not include the concentration of water. Fine.
Right.
Okay, so one more point from this one. One is order and molecularity of reaction. Order and molecularity of reaction. You have any idea? You might have heard somewhere. So see, molecularity is how many number of molecules are reacting. That is called molecularity.
Wait, that C is stoichiometric constant also, right?
Stoichiometric coefficient, no, but how many total molecules are colliding each other to form a product? Just we will see molecularity. So basically how the reactant or how the reaction is proceeding. Suppose we have reactant to product, so these all reactant will collide to each other. They will collide and they will have some effective collision. We will see in collision theory in further classes. So they will collide each other and then they will form a product. So how many molecules are colliding or participating in the reaction, that we call it molecularity. Okay, so the number of reactant molecule which collide in a single step, number of molecule which collides in a single step reaction, not multi step, in a single step reaction. If we have multi-step reaction, then that will be a complex reaction. Like this was a complex reaction A, which we have seen that formation of C. So that was a complex reaction. So this we are talking about single step reaction. In one step only the reaction is completed, not several steps. So in a single step reaction to form product, is called molecularity. Fine. So the molecularity can be unimolecular also. Suppose any one molecule is colliding, so that is called unimolecular. So unimolecular, so molecularity will be 1 is equal to 1 means only one molecule is colliding each other. So example can be bromine 2, this is one molecule of bromine, it is forming, it is breaking into bromine gas, you can say it is also bromine gas, but this is one molecule and it is breaking into one atom or two atoms of bromine. This is molecularity of 1. Okay, then there can be bimolecular also, when two molecules can collide each other. So bimolecular means molecularity will be 2 is equal to 2. So there can be two molecules, suppose hydrogen gas is there and one more molecule, you can say iodine gas is there. So these two molecules will combine each other and it will form 2Hi. So this is bimolecular, this is unimolecular, this is bimolecular. There can be trimolecular also, where three molecules will combine together to form a product. Okay, but here I have said that they collide with each other. Okay, so the possibility of colliding of three molecules is very less and four molecules is very less. Okay,
Like three molecules, as in three separate molecules. Say H2, I2, and H2O.
yeah,
That is
see
trimolecular.
basic how the reactant will be. Here there will be one molecule, here there will be another molecule. How the
No,
reaction?
say in this reaction, I add a H2O also. That means it's
Just
trimolecular.
wait a moment. So what is happening here? these molecules are colliding and then they are forming product. Okay, so what is the possibility that these two molecules can collide? There is a huge possibility that these molecules can collide each other. Okay, now if I add one more molecule, okay, so these three will collide, but what is the possibility that these three molecules will collide at the same time? So of course these two can collide, so this one will be left, these two will collide, so this one will be left, these two will collide, so this one will be left. You understood what I am saying? All the
So will
three
proteins
molecules,
all be formed?
no, all the three molecules should collide at the same time. If this will collide with this one, then some other product will form. If this will collide with this one, some other product will be formed. So to forming the exact product, these three molecules should collide at the same time. That's what I want to say. Okay, so molecularity is basically, this is a theoretical quantity. We are assuming that these three molecules are colliding each other. First write it down, this point. Molecularity of a reaction is a theoretical quantity. Molecularity of reaction is a theoretical quantity. Okay, we are just assuming that these molecules are colliding to each other and they are forming product and they are colliding at the same time. Okay, but this, we have three molecules, so of course possibility will be less that they will collide at the same time. And if I write one more molecule here, if I take one more molecule, then here the possibility will be very less that all the four will collide at one point. You got my point?
Tetramolecule.
You got my point or not? That there is very less possibility that all the four,
No, but say it is A, B, C. It can't form products like A, B, B, C, C, A.
yeah, but
Not
it will
possible.
be a complex reaction, not single step reaction. It
Uh-huh.
will be a complex reaction. Got it? So that's why
Mhm.
molecularity of reaction cannot be more than 2. This you need to remember.
Okay.
Molecularity of reaction cannot be greater than 2. Greater than 2, not greater than 3. See, there is one topic known as collision theory. We will see in chemical kinetics. There we will study that whatever the molecules is there, when they are colliding to each other, then there should be some effective collision. It doesn't matter that it should just touch this one and the product will form. It should be head-on collision. Head-on collision, then only product will be formed. If they are just touching each other, then it will not form. Head-on collision. So if I write 4 molecule here, so what is the possibility that all the 4 molecule will have a effective head-on collision? It will be very less. Maximum,
Low probability.
yeah, the maximum 3 molecules can collide to each other with a head-on collision, but fourth one will
Mhm.
not collide. So since this is a theoretical quantity, that's why it is not greater than 3. It is maximum to 3 only. Okay, fine,
Okay.
fine. One more point, that molecularity of reaction cannot be 0. Why? At least there should be at least one molecule. The molecularity of reaction cannot be 0. Okay, and cannot be negative also. Why? Because what is negative number of molecule? It is not possible. At least there should be one molecule. 0 molecule should not be there, negative molecule should not be there. So this is, it can't be 0, it can't be even negative also, it can't be even fractional also. Okay, so can't be 0, negative, fractional. This you need to remember. Can't be fractional or can't be infinite or even infinite. So this is a theoretical quantity. It cannot be greater than 3. It cannot be 0, negative, fractional or infinite. Okay, got it? So these 3 points you need to remember. Fine. So there can be, if it is more than 3, if it is more than 3, then that is a complex reaction. Like suppose you can write one more point. If molecularity is more than 3, if it is more than 3, then it is a complex reaction. Complex reaction means multi-step reaction.
Hmm.
Like see, I have taken the number of molecules. So suppose I take this example, 4HBr plus O2 gives 2 bromine plus 2H2O. So here if I need to write molecularity, so what will be the molecularity? 4 plus 1 is equal to 5. but I am saying that it can't be greater than 3, but here we are getting 5. Why? Because 4 from here, 1 from here, so 5 can't be possible. So this will be a multi-step reaction. So we will presently we will not see what
So
is.
even if it's the same type, we take it as four different.
Yeah, it will look 4 different steps, so each steps we need to count. Okay, we need to consider only single step reaction. So this is a complex
Hmm.
reaction. So there will be some different steps. First, initially HBr will react with oxygen and it will form HOOBr, then HOBr will be formed, then again HOBr will react. So there can be several steps. Okay, so this we are not counting for complex reaction. We will see in separate topic what is this complex reaction. Okay, but it can't be more than
So
3.
this is a complex
Yeah, this is a
reaction.
complex reaction. Whenever molecularity you are getting more than 3, then it is a complex reaction. Okay, the next term we have order of reaction. So this was a theoretical concept. Order of reaction is a experimental concept. Okay, so order of
Hmm.
reaction is the sum of power of all the concentration terms. This is the sum of power of all the concentration terms included in the rate law, what we have seen just now. Write it down. The sum of power of all the concentration terms, all the concentration terms, whatever the concentration you are taking, all the concentration terms included in the rate law, included in the rate law means we had one reaction of N1A plus N2B plus N3C, it gives product. So what was the law of mass action? Law of mass action means rate. How we have written? Rate is equal to some rate constant K into concentration of A to the power N1, then concentration of B to the power N2, then concentration of C to the power N3. So what I am saying, the sum of the power of all the concentration terms included in the rate law. This is the rate law. So power of the concentration means this one plus this one plus this one. So that is called order of the reaction. So here the order will be, order is equal to N1 plus N2 plus N3. That's it. This is called the order of reaction. Got it?
Okay, that's the
Yeah, that's it.
stoichiometric.
That's it. Just this is just the order. Whatever the
Hmm.
power is given, just add all the powers. That will give you the order of reaction. Okay, simple. So this is an experimental quantity. This is right the characteristics. This order is a experimental quantity. Molecularity was a theoretical concept. Order is an experimental. You need to do experiment. Then you,
This first will be given the reaction, we
yeah,
should balance and then we can find, right?
yeah, we can find. Not exactly balanced, they will give concentration terms with respect to time, then you have to calculate the power. We will see, just see it one by
Uh-huh.
okay.
But will we be given the reaction?
Reaction will not be given, the change of
Oh.
concentration will be given.
Then how will we be able to find N1?
If reaction is given, then directly you can write N1 plus N2 plus N3.
Uh-huh.
If reaction is not given, then based on the change of concentration you have to calculate the power. Rate will be given
Obviously.
and concentration terms will be given, so you need to calculate the power. Okay, we will see. Okay,
Mhm.
this order is an experimental quantity. It is an experimental quantity.
Right.
Fine. Then it can be fractional, zero, negative. Molecularity could not be fractional or negative, but order can be fractional, zero or negative. Okay, so the order, there can be one, two or three marks question differentiate between order and molecularity. Okay, so this you need to remember. Order can be fractional, then it can be zero, it can be negative, but
Wait, how
can,
is negative
yeah,
possible?
it is possible. It is possible because this is experimental quantity now. It is possible. We will see some questions where negative will come. Okay, negative, but not infinite. There are some reaction, pseudo order reaction. Okay, there it will come
Huh.
negative. Pseudo order reaction we will see anyway. So as we proceed further, you will know everything. Okay, just go slowly. So this is can be fractional, zero, negative, but cannot be infinite. Okay, and this point order can be greater than 3. Molecularity cannot be greater than 3, but order can be greater than 3. Order of reaction can be greater than 3. Fine. So this was like for order of reaction. Okay. So suppose if any question is there, if any question, rate is equal to some rate constant K, concentration to the power 2 into concentration of B to the power 1. So order, what will be order? Order will be
3, right?
3. Simple. Okay,
Hmm.
fine. Now suppose we have some experimental quantity, then you need to calculate the order. We will give some concentration here. So suppose one question is given, reaction 2A plus B gives C. Okay, this is the reaction. So here we are doing some experiment experiment number this is and concentration of A they have given.
No, would the order be 3 in this case also?
No, here order will not be 3 in this one. Okay, here order cannot be 3. Okay, we need to determine from the experiment. Okay, we need to determine from the experiment. Okay, fine. Then concentration of B in they have given concentration of A, this was concentration of B they have given, and the rate they have given. Suppose this is rate they have given. This is the experiment number 1. The concentration of A at some time was 0.1 and the concentration of B they have given 0.1 and the rate was 4 into 10 to the power minus 4 unit you can take the moles per liter. This is the first part. Okay, then second part they have given this rate was 0.3, no concentration, here also concentration 0.3 and the rate was 1
This is
into,
given to us,
yeah, this
right?
is given, all the data is given to us, into 10 to the power minus 3. Then I should have taken one more line. Anyway, just see 3, experiment number 3 we have 0.1, then we have again 0.3, then the rate is 4 into 10 to the power minus 3, then the fourth data we have 0.2, then this we have 0.4 and the rate is 8 into 10 to the power minus 4. Okay, shall I rub here above? So this data is given to us. Okay, then we have to find the order of reaction. Okay, so the order of the reaction, what is the order of reaction? Rate is equal to K into concentration to the power n and concentration of B to the power n2. If we are able to calculate n1 and n2, then we can get the order. It is not likely that A to the power 2 and B to the power 1 because this is an experimental quantity. So what we need to do, rate, this rate is given, this rate is given to us. Okay, concentration of A they have given, here concentration of B they have given, then we have to compare two rates, rate 1 by rate 2, and then we have to calculate the value of n1 and n2. Understood what we have to do? So you have to compare, suppose this I will write experiment number 2 and 3. So you have to compare two rates in such a way that one of terms will get eliminated, one of the terms will get eliminated. Okay, so if we will divide this by this, then anything will not get eliminated, but if we divide 1 by 3, then this term will get eliminated because 0.1 and 0.1 will get eliminated. Okay, understood or not? Okay, so I will see rate 3 divided by rate 1, so R3 by R1. So R3 by R1 means K will get, anyhow it will get cancelled. First write R3.
No, wait. R3 by R1 as in
What is R3? Write R3 is equal to K into R3 0.1, concentration is,
K is the rate,
yeah,
right?
K is the rate constant, K is the rate constant, not rate. Rate is R, R3.
No, the last one over there, 4 into 10 to the power minus 4, those are the rate constants.
Not rate constant, these are rate. Rate and rate constant are different.
Hmm.
What was the rate expression? Rate expression, rate is equal to K
Okay,
into concentration of B, A into
what is
concentration
the
of
value of K? What do we substitute as K?
K is not given to us. Just hold
Uh-huh.
on. Okay, K is not given to us. This is rate which they have given, and rate constant they have not given. Concentration of A and concentration of B they have given. Okay, so if we write R3, so write this is to the power x I will write. Okay, I will write x. Then y term, what we will write for 3? 0.3 to the power y can I write?
Okay.
Can we write? Okay.
Right, right.
What we will write for R1? R1 will be K into, just tell me for R1.
0.1 to the power x? No.
Yeah, to the power x, of course.
Same value.
Yeah. And then for y?
0.1.
Yeah. So 0.1 into y. Okay. So if we will divide R3 by R1, so this term will get cancelled and K will also get cancelled. So R3 by R1, what it will be value? Means divided by R1. So this term will get cancelled or not? This K will get cancelled, this 0.1 and 0.1 will get cancelled.
So 0.3 by 0.1
Yeah.
whole to the power y.
Yeah, 0.3 divided by 0.1 and whole to the power y. And what is R3 by R1? They have given R3 is 4 into 10 to the power minus 3 divided by 4 into 10 to the power minus 4 is equal to 0.3 divided by 0.1 to the power y. Can we say this thing? Yeah. So what will be this value? Can we calculate here?
So R3 by R1 is also equals to 4 into 10 to the power minus 3
Yeah.
by 4 into 10 to the power minus 4.
So can we get this value, or can we reverse this value? If we can reverse this value, then what this should be R3. R3 is this one, so 4 into 10 power minus 3 divided by R1 is this one. So if we will divide this value, this which one is greater value? This one is greater value, 4 into 10 power minus 3. So can we simplify this reaction?
So it becomes 10, right? 10.
It will become 10. It will become 10. Yeah, of course it will become 10. So if I am writing 10 is equal to 0.3,
10 is equals to 3 to the power y.
3 to the power y. I think we did some mistake or what?
No, 0.3 and 0.1 will become 3, right?
But what will be the value of y so that it will become 3?
We take log then.
No need to take log. No need to take log. I think we missed in writing some data. Let me check once more. Just let me check once more. This is experiment number 1. This is 0.1. This is also 0.1. This is 4 into 10 power minus 4. Fine. This is 0.3 and this is 0.3. This is 1.2 into 10 to the power minus 3. This is also fine. This is 0.1. This is
We
0.3.
didn't really use those, right? We only used 3 and 1.
Yeah, this is wrong we have taken. Okay, this is not 10 to the power minus 3. This is 10 to the power minus 4.
So then becomes 1, right?
Yeah, 10 to the power minus 4. This is
0.3 to the power y is
8
equals to
into
1.
8 into 10 to the power minus 4. Okay, so this is this is not 0.3. This is 0.4. So this is also 0.4. So this will become 1. Okay,
1.
so this will become 1. So it means 1 is equal to 0.3 to the power y. So what will be the value of y? Now we can get the value of y. So can we write y is equal to 0? Can we write?
Okay.
We can write y is equal to 0. So the power terms in terms of this y will be 0. So we have got y is equal to 0. Okay, fine. Now you take these any two other reactions, any other two experiments, and try to eliminate y and try to get x. So which two reactions should we take so that this y will get eliminated. Shall we take 2 and 3?
Yeah.
So this will get eliminated, 2 and 3. So this divided by this will get eliminated, this will be remaining. Okay, so we will say R2 by R3. So R2 by R3, the rate will be,
Wait, what do we really have to find in this question? These stoichiometric
yeah, we have to
constants.
find x and y we have to find.
Why we found
Y we
0?
have found 0. So now we have to find x. So x we need to find, so we need to eliminate this part, then only we will get this part now. Okay, because a to the power y, so we will have this value and this value we should not have. Initially we have eliminated this part, so this value was not there, so this value we have got it. Okay, okay, so this is R2 by R1. So R2 by R1 means this divided by this, so 1.2 into 10 to the power minus 3 divided by 3 is 4 into 10 to the power minus 4. Is this okay? Is equal to, so that is equal to this part, this will get cancelled out, so 0.3
3.
divided by 0.1 to the power x. Okay, got it? So is equal to, so this term will be 3, I think this term will be 3
Equals to 1.
yeah. So 3 is equal to, then 3 to the power x we can say,
This is 1.
so x is equal to 1. So now overall what we have got here, what we have got, so here we have got x is equal to 1,
So in second case, what did we take? R2 by
R3 by R1 we have taken.
R3 by R1.
See, first you take anything which can eliminate one term. Okay, so if we will take these two terms, then one term will get eliminated. Basically this we are doing some kind of mathematics so that only one term can be remaining. Okay,
Oh, right.
okay, so you take any of these two. I will give you one shortcut trick also, no need to worry, this is a long trick. So if I'll take these and this, so this term will get eliminated, this we will get. If I'll take this and this term, then this and this term, so this will get eliminated, 1 and 0.1, 0.1 and 0.1, we will get this value. Okay, so once we have got x and y, so x is equal to 1, so rate is equal to like what, rate is equal to this some constant k into a to the power 1 and b to the power 0. So the order is equal to first order. Got it?
Right.
Order is equal to first order. Got it? Now you see, you need to remember one trick. Suppose how I can give you one trick. Let me save this one. Save as, this is kinetics JPG already we have. Now we have written rate is equal to some rate constant into concentration of A into concentration of B to the power, suppose I have taken only one, A to the power n. Okay, this n is equal to order. Fine. Then if you change the concentration, suppose if you change the concentration, if you double the concentration, if we double the concentration of A, okay, then rate becomes double. If we double the concentration of A, then rate also becomes double. Okay, then this value, if it will be 1, then only it become doubles. If this value is 1, understood or not? If we double the concentration of A, rate also becomes double. So n should be 1 only, double, then order is equal to 1. This is okay. Now fine, if we double the concentration, then there is no change in rate. If we double the concentration, then no change in rate. No change in rate. So no change in rate means this will be 0, then only there will not be any change, because whatever we do here it will become to the power of 0 is equal to 1, so rate will be the same only. So order is equal to 0. Can we say? Now if we double the concentration, then rate becomes 4 times. Now rate is becoming 4 times. If we are doubling this concentration, rate is becoming 4 times, then what can be the order? What will be the power?
Would it be 1 or 2? No, 1 itself.
If we double, then rate is becoming 4. Okay, so 4 means we double means 2 a square. 2 a square is 4, then n will be 2.
Okay.
Got it? Then
2.
order is equal to 2. And if we double the concentration, rate become 8 times. If we double the concentration,
2 to the power 3?
yeah,
3.
rate
Order is
becomes 8 times, then order is equal to 3. So you need to see the change in concentration of A and change in concentration of
Wait,
B.
can you explain that part? Like, how do we find it using the reaction? That part again once.
Yeah, that part of reaction we will see. Okay, now
No, like using the reaction, how we found 102 and all.
102. No, I didn't get what you
Like,
are asking.
yeah, this reaction rate reaction. How did we find it was 10? That can you just explain that?
Okay, one more time. Okay, no problem. So whatever the reaction will be given to you, so how you will
Huh.
calculate the rate? Basically, if I'll take this reaction, they like any experimental part we will take. Okay, anything, suppose we have taken 2a plus b gives 3c. Okay, so what will be the
Okay.
rate? How we will write the rate expression? So rate expression, we will write some rate constant k into
Hmm.
concentration of A. Initially it looked like this is a power of 2. Okay, and then product concentration of B to the power 1. But since I have told that this is experimental quantity, that's why we don't write here directly 2. We need to determine the value of this A.
So that value of 2 is not correct.
Yeah, value of 2 is not correct, so I am taking it as x and I am taking it as y. If we will get
Okay.
x and y, then we can get the order by adding x plus y, we will get the order. So this,
Hmm.
from this equation we can know. Is this okay? So
Hmm.
we have some data set, because we have to calculate through experiments. So we have some different experiments. So experiment number 1 is there. So we have the concentration of A and concentration of B, and we have a rate. ठीक है? Then the concentration of A is 0.1, then concentration of B is 0.1, then rate is equal to 4 into 10 to the power minus 4. So how will you write rate for this experiment? So rate is equal to rate into
0.1 to the power
so
x,
here we will
0.
write 4
Why?
into 10 to the power minus 4 is equal to k into 0.1
Yeah, here I understood.
into to the power x, then 0.1 to the power y. This we got it. Then we have another experiment, experiment number 2. Here we have 0.3, then again we have 0.3, then rate is given 1.2 into 10 to the power suppose minus 3. Then how we will write rate for this one? So here it will be 1.2 into 10 to the power minus 3 is equal to k into how much? 0.3 to the power x into 0.3 to the power y. Is this okay?
Right.
Is this okay? Then
Understood.
again third part. Again third part, we have concentration of A is given 0.1, then again concentration of B is given 3, then rate is given 4 into 10 to the power minus 4. So how will write rate expression? 4 into 10 to the power minus 4 is equal to k into 0.1 to the power x into 0.3 to the power y. Okay, so here we have equation 1, you can say. Here we have equation 2, here we have equation 3, and one more we will have equation 4. So from this 4 equation we need to determine x and y. Okay, so if we will do 1 divided by 2, 1 divided by 2 or 1 divided by 3, whatever we will do, then this k will get cancelled out, this will get cancelled out, and
K will anyways get cancelled out,
yeah,
huh?
k will get cancelled out anyway, but we have to choose in such a manner that one of these two terms will get cancelled out.
If we take the first and the third one, 0.1 to the power x gets cancelled out.
So if we will take this and this, so this divided by
Huh.
this, we will get some value, so this
Huh.
0.1 and 0.1 will get cancelled out,
Cancel.
and we will get
Huh.
y term.
Huh.
Got it? So we will get y
Huh.
term. So from using these two equation, you can get the y term. Now
Huh.
if you will use these two equation, then this is not getting cancelled out. We will use these two equation, because if you will use 1 and 2, then nothing is getting both is getting cancelled out. So
Huh.
like nothing is getting cancelled out. Basically this is 0.1, this is 0.3, this is also 0.1, this is also 0.3, so nothing will cancel out. But if we will use 2 and 3, then this will get cancelled out, so we will remain with this one, k will also get cancelled out, so we can get x from here. Got it? So whatever the data is given to you, you just pick and choose what kind of data is available, so that you can cancel one of the term and you can get the another term by writing this rate expression.
Okay.
Understood?
Okay.
And this is one,
Understood.
and this is one trick that you can choose here, like this is the second order, like second order was for which one? We calculated that for y it was 0 order, and for x it was first order. This one only we calculated from the equation. Then see whether we are getting the data or not in this one. So initial data was, see, once the concentration was this one, concentration of A, and yeah, see, so here the concentration of A was 0.1, concentration of B was 0.1, the rate was this one. Fine. Then we have not changed the concentration of A, but we have changed the concentration of B. Okay, so whatever the change we have done concentration of B, is there any change in the rate? Can you see any rate change in the rate? This was also 0, 4 into 10 power minus 4, and this was also 4 into 10 power minus 4. Can we see any change in the rate?
No change.
No change. No change means this concentration of B to the power term will be 0. That's why this will be a 0 order. For 0 order reaction, whatever you change you do, there will not be any change in the rate. Just now we have seen. Got it?
Okay.
Yeah. Then for the second order, A was second order reaction. Okay. So initially, then we need to see, yeah, from this one. Okay. For this one, this is initially it was 0.1 and it was 0.3. The rate was this one. Fine. This was 0.1, this was 0.3, the rate was this one. Now for this one is remaining the same. Now we have tripled the concentration. This concentration we have tripled, 0.1 to 0.3. What is the change in the rate? It has also increased 3 times. Just see, this is also increased 3 times. Okay, so 3 times we have increased 3 times, so rate also has increased 3 times. So of course, how many times we have increased, that time we have increased, so this rate will be first order. If it have increased 3 to the power, it would have increased 9 times, then this order would have been second order. Understood? Understood or not?
Right. No, understood.
Now understood. So you can solve either by seeing, by looking the equation, or if you are not able to follow the equation, just do simultaneous equation. This simultaneous equation will take some time, but it will not give you a wrong answer. Is this okay?
All right.
Yeah. So we will continue with the chemical kinetics in the next class. So till now you just read any book, read any NCERT book and just go through, okay? Or you go through your LN notes also, no problem.